Bueno, buenas tardes. Ahora nos toca hablar del apasionante mundo del cambio climático y la influencia que la gestión de residuos puede tener en las políticas de cambio climático y cómo luchar contra él. Nos acompañan Bettina Kamuk, que viene en representación de la compañía RAMBOLL y es miembro del grupo de recuperación de energía de la International Solid Waste Association. Josep Garriga, economista en representación de la Fundación Fòrum Ambiental, y Crawford, que viene en representación de la International Solid Waste Association, aunque su carrera profesional, trabajo profesional lo desarrolla dentro del grupo VALORIZA. Pues nada, cuando quieras, comenzamos.
Thank you. I hope it will work. So thank you very much for being invited to make a presentation today about the role of waste to energy as a part of the renewable energy supply. I will just say some few words about the company RAMBOLL, just for you to know my background and what I have done before standing here today. The company is a consulting company. It was established back in 1945 by the two gentlemen you see on the photo here. We have grown since then, and today we are close to 10,000 employees doing consultancy in different areas, among others waste to energy. And we consider ourselves to be one of the leading waste to energy consultants in Europe, with more than 60 specialists dealing only with waste to energy. Actually, I think today we are 65 person dealing only with waste to energy. We have a long track record of waste to energy facilities, and at the moment we are doing around 35 ongoing projects worldwide. And just briefly, our references, we have pointed out on the world map where we have done projects, so just for you to see that we are, of course, we are focused a lot on Europe, but we have also done a lot of projects worldwide. At the moment, I would say the main activities in Europe is in UK, because they have lagged a little behind the other European countries, so they have to do a lot in order to fulfill the landfill ban. And you can also see we have done or are doing projects in, among other, United States and also in the Far East area. One project that is not mentioned here is a new project in Abu Dhabi, where they want, due to the renewable part of the energy, they want also to go for waste to energy. Not because they lack oil or fossil fuel, but because they wanted to have the renewable part of the energy. You have heard earlier this morning from WTRT how many facilities we have worldwide. In total, it was around 1,200 waste-to-energy facilities. In Europe, we have more than 460. I think this slide is actually, I think if WTRT slide was from 2009, this is from 2010. And since then, I counted during the presentation earlier this morning, and there are 30 more facilities on this slide than the one you saw before. So waste to energy is still a growing business in Europe for sure. Around 66 million tons per year are incinerated at the European facilities. And if all European countries have to fulfill the landfill ban, the amount of waste to incineration will double at least. I will come with some examples from Denmark. I am living in Denmark, and of course we have done a lot of waste to energy projects in Denmark, and I will focus a little on the Danish aspect to give you an idea of how we look at waste to energy in Denmark. We started back in 1997, where we introduced the landfill ban. It was very early compared to the other European countries. Now we have in all EU, as you know, the landfill ban. We started actually back in 97. By that time, it was introduced at the same time as we introduced a tax on the landfill. We heard earlier this morning about the question about the tax. And in Denmark, we started with the landfill ban, then later on we introduced also we had the landfill tax, and we introduced later on the tax on waste to energy. Today we have a tax at around 50 euro per ton of waste. So we have a tax on landfill, we have a tax on waste to energy, and we do not have a tax on recycling. Of course, that is the incentive to send as much as possible to recycling. We have in total around 68% of the total waste stream is going to recycling in Denmark. So we have actually fulfilled the goal that the Danish ministry set up some years ago. But of course the goal will be more stringent for the years to come. And for certain it will be focused a lot on preventing the loss of resources. We heard also earlier this morning about the roadmap in the European Union. And for sure that is something we will focus on in Denmark as well, to ensure that our resources will be kept. We also go for zero growth in waste in conjunction with the economic growth. We are not there yet, I would say. I don't know if we will be there, but at least that is the goal. And then of course we want to improve the quality of waste treatment and increase the efficiency. If I should point out what is up for discussion right now in Denmark, I would say that is the separate waste collection of the bio-waste. We started that in the 90s. Actually, a lot of Danish municipalities introduced separate collection of bio-waste. We set up anaerobic digestion facilities. Some operated with very huge technical problems. And a very prestigious project was actually closed in Denmark. So even though all municipalities had introduced separate collection, everything was closed after a while. We still have the 2 waste bins, but we do not do anaerobic digestion in the greater Copenhagen area anymore. But it is up for discussion again. At those time, back in the mid-90s, the Danish EPA set up a study concluding that under the Danish circumstances, it was as good to send the bio-waste to incineration because we have the high energy efficiency on our facilities. But all that is up for discussion again. So I cannot tell you how that ends, but it might be so that we will again introduce separate collection of the bio-waste. At least that is heavily discussed right now in Denmark. But waste to energy is very widespread in Denmark. We have a long tradition, more than 100 years tradition of waste to energy, and in total we have 29 plants today. In total they incinerate approximately 3.5 million tons of waste a year. Maybe I should mention that we are 5.7 million inhabitants in Denmark, so it's not so many inhabitants, but a lot of waste to energy facilities. The size of the facilities are differing a lot. The smallest are around 20,000 ton per year, and the largest facilities around 500 ton per year. So the size are very different from the size of the city to the other. As you can see on the slide here, the waste to energy contribute quite a lot with the electricity. 3 to 4% of the total electricity supply in Denmark actually comes from waste to energy, and for heat it's even more. It's around 20% of the total district heating consumption is actually coming from waste to energy. So it's quite an important part. But it's not only energy that plays a role. We also have the biomass, and I have set a question mark. Could we call it urban mining? We heard about urban mining earlier this morning as well. And I think that is something that we will see in the future, that today in Denmark we recover the ferrous and the aluminium metals, and I'm sure that we in the future will see more of the critical metals that will be recovered from the biomass. So I think that is the tendency for the future, that waste to energy will be a part of the urban mining. And the sector has to do much more in order to recover the critical metals from the biomass. It is possible, but of course it's a matter of financing. Maybe I should also mention that approximately 100% of our biomass after separation of metal is going for construction purposes. But waste to energy is not only part of the waste management policy, it's also part of the Danish energy policy. And in 2010, the Danish Climate Commission came up with a conclusion stating that in 2020, 25% of the energy has to be from renewable sources, much more than the general European target on 20%. We wanted to go for 35%. And in 2050, it has to be 100% renewable. That's quite ambitious. And in addition to wind will be a growing market in Denmark. But I took a quote from the Danish Climate Commission stating that waste shall play a central role in the development of a green and long-term energy system in Denmark. And I think that's very important, that it is supported both from the environmental ministry, but also from the energy ministry. And that has helped a lot in Denmark to implement systems. The picture here is a very good example of how we do it. It is maybe some of you have maybe visited Copenhagen, and when you drive from the airport to the city, you will see this picture here. You can see the wind turbines. They supply, of course, to the energy supply. Here we have the power plant operating on fossil fuel and biomass. And this stack here is actually the waste to energy facility. So I think that's a good picture showing how we do energy supply in Denmark. On the next slide, you can see the district heating network in Copenhagen. We have heard a lot about that this morning, that it's not always so easy in the Southern European countries to do district heating. And of course, it is easier in Denmark to do that. This district heating network is approximately 50 kilometers from this side to this side. And there are 3 waste to energy facilities connected to the same grid. On the left side here, it's 300 ton per year, and the biggest here is 500,000 ton per year. We also do district cooling, even though it's often very cold in Denmark and in Copenhagen. We also have a district cooling system, and I think that will be growing over the next years. The waste to energy facility in Copenhagen is up for renewal because it's an old facility dating back from the 70s, and it has to be upgraded now due to new technology and higher efficiency. This slide here is taken from the brochure from the Danish municipality, and they stated that waste is not a waste, and this illustrates that the waste is generated in the city and the energy has to be used in the city. The municipality is focusing a lot on the climate change, and they have a strong ambition to reduce the carbon footprint, and for certain waste to energy contributes a lot to that part. I will come back to that a little later on. This slide also shows where the waste to energy facility is located, and as you can see, it's really in the city center. The red circle here is the waste to energy facility. It is only 2 kilometers from the city hall, 1 to 2 kilometers from the opera house, and only 4 kilometers from the Queen's Castle. So it's really in the city center. The managing director of the facility is quoted for this, what you see here, that we want to show the world that it is actually possible to produce energy for the city, and that it is possible to do it in the middle of the city. It is important that the waste to energy plant is integrated into the environment, and the architecture should be a gift to the city. You have seen this photo before in the WTRT presentation this morning, and the architecture was selected after a bid where 6 architects participated. And this architecture was actually selected mainly due to the fact that it could fulfill the technical requirements, and it also integrated a lot the recreative part of the area. It was a strong wish from the municipality that the plant should be open for the public, and maybe you cannot see it very much on this slide, but actually this is an artificial skiing slope. We do not have hills or mountains in Denmark, so the idea of the architect was to introduce an artificial skiing slope, and also to open up for the citizens to come there and walking around this green area. And I think it is a very good architecture, and it has been very well accepted. There have not been any public opposition against this facility. RAMBOLL did the pre-investigation to come up with the concept. We did the tender specification. We have done contract negotiation, and the contract has actually been ready for a while. And I can announce to you that the contract will be signed tomorrow. So it's a big day for us tomorrow, where this plant will continue working. And the plant will be ready in 2015. The question this morning was if there were any financial incentive for the city that hosted a waste-to-energy facility. I can tell you that for this plant there is no financial means following this plant, but of course the city will have the district heating from the system, but there will be no financial means following the hosting of such a facility. There was also a question, I remember this morning, to the name waste-to-energy instead of incineration. Actually, one of the reasons that it took a while before the contract could be signed was that the municipality wanted that the plant should change name, because today it's called Forbrænding. In Danish it means the incinerator located in this part of Copenhagen. The municipality wanted that it should not be called incineration anymore, because it should also do, of course the target for recycling is very high in Copenhagen, so the company will change name to something with resources or recycling. So I think it was a good question that came up this morning. The slide here illustrates that it's not only a nice architecture, but actually it can also contain all the mechanical equipment. It is a very traditional scheme, you could say, where the waste is coming in, unloaded in the bunker, it's feeded into the hopper with the crane. Here you have the grate, and this is the boiler, turbine generator, and the remaining stuff will be the flue gas treatment. The city of Copenhagen decided to go for a very sophisticated and advanced flue gas cleaning system. For sure, this is not the cheapest solution, but they decided to go as low as possible. So what they did was that they had a low dust, high temperature catalyst system here. In order to have the low dust, they have the ESP in front of the catalyst system. Then they have the economizer after the SCR. Then they have a quench and an acid scrubber and an alkaline scrubber. They produced wastewater that is discharged to the sewer system. And then we have the ID fan and the stack. For certain, there are also alternatives, and many of the Danish facilities have a more simple system, as you see here. They have an SNCR system where they introduce ammonia into the boiler at the right temperature, and then they add lime and water to a reactor, and then they have a backhouse filter, and then directly to the stack. Both solutions are fulfilling, of course, the environmental, the EU directive of emission limits. But the Copenhagen facility wanted to go as low as possible. Most of you have probably seen these figures before. That is from the EU BREF, the best available technology and operational emission limits. So that this means that is actually what could be done in practice. And the Copenhagen facility wanted to be on the very low end. They will be here with the NOx and very low on the emission on the other pollutants. We heard this morning about the energy efficiency. It was the WTRT presentation, and we also heard about the plant in Naples, in Acera. Actually, I have come directly from Naples this week because RAMBOLL is engaged in Naples in order to see what we can do, because they have high corrosion in the facility due to the high steam parameters. So we are trying to rebuild a little bit the plant, and they have been forced to reduce the steam parameters. So for certain it's important to go up in the high efficiency, but you also have to take care of corrosion. For the Copenhagen facility, we have made this analysis to see what makes sense in order to have the right steam parameters. And the plant decided to go on 70 bar, 440 degrees Celsius. As you can see here, if we go up to 48 degrees. The Naples facility was actually 500 degrees. And you can see the reason for this curve here is that you have a very high corrosion in the superheaters, and of course it costs a lot of money to exchange superheaters, but also to exchange the panel walls. So coming a little back to the renewable part of energy, how much energy can you actually get out of the waste? As a rule of thumb, I would say that if you have 1 ton of waste, you can produce 2 megawatt-hour heat and 2/3 megawatt-hour electricity. You can do a little to change the electricity supply, but that is as a rule of thumb. A part of the energy will, without doubt, be defined as renewable. That is what comes from the biogenic part of the waste. But principally, it's not up for the waste-to-energy facility to decide what is renewable and what is not. That is the producers of the equipment, you can say. If you have a spoon, it's illustrated, It's illustrated by the spoons here, that if you decide to produce a spoon by wood, then the energy that you produce in the incineration plant is defined as renewable, as the green circle here. If you decide to produce the spoon by plastic, then the CO2 that comes out of the stack is defined as non-renewable, even though you actually save fossil fuel. So seen from a waste-to-energy perspective, you could say that that is not quite fair, that even though you prevent the use of fossil fuel, you cannot really get the credit for that. By 1st of January 2013, 10 of the Danish waste-to-energy facilities will actually be part of the European trade system. So by 1st of January next year, all waste-to-energy, or these 10 waste-to-energy facilities in Denmark, they have to count, to measure how big a portion of the CO2 is coming from the renewable part, from the biogenic part. And they will do it either by carbon-14 measurement, or they will use a system developed by the University of Vienna called BEOMA, where they can calculate how much CO2, and they are equal in the quality. So it will be quite interesting to see how it goes. We heard the figure 80% of the Danish waste was renewable. Actually, this figure has been corrected since the presentation from WTRT. Today, it is 70% of the waste is biogenic. That means that 54% of the energy in Denmark is called renewable, and 60% of the CO2 emission is called renewable. So keep in mind when you hear percentage that you can either talk about the part of biogenic part in the waste, you can talk about the renewable energy, or you can talk about the renewable part of CO2. And those three figures are not the same. That's important when you hear the figures. This is to show, under the Danish circumstances, how much CO2 can you actually save by using waste-to-energy. And the idea is here that you have if you have 1 ton of waste, you can, in Danish circumstances, you can generate 10 gigajoule heat and power. And if you send this ton of waste to a landfill, you would have this CO2 emission. Methane emission is excluded, so we are only talking about CO2. And at the same time, you should produce the same amount of energy by fossil means. You can do that by coal, oil, or natural gas, and you will have the blue part that is from the fossil fuel. If you use a ton of waste to produce a 10 gigajoule heat and power, you will have this amount of CO2. So what you have saved is between this and this point if it's coal, and then if you use oil or gas. I just calculated when we heard the presentation from Lipor, and actually they came up to the same amount, that it is 0.5 ton CO2 savings per ton of waste. What does it cost? As a rule of thumb, we say that for a yearly tonnage, the investment cost is 700 to 900 euro per ton per year. The Copenhagen facility, as you saw before, the cost will be around 900 euro per ton of waste. With amortization, operation, and maintenance, you will have a cost of 120 to 140 euro per ton. In Denmark, we can sell 2/3 megawatt electricity, and it means that we will have an income of 40 euro per ton. But we are also in the lucky situation that we can sell the heat, and it means that we will have an extra income of 60 euro per ton. So in total, the treatment cost in Denmark is between 20 and 40 euro per ton of waste. And then we have the tax on top of that. So we just want to compare with what does it actually cost, and we say it is exactly the same as you pay per household for the empty rubbish sack, just to put it in, to compare with something else. So it is actually not so expensive if you look at the household. I can see that I'm run out of time, so I will just briefly show this. I will not go into a discussion about the technology, but we heard from WTRT this morning that the Great Fire technology is a mature and well-proven technology implemented in much more than 1,000 plants worldwide. When you are listening, it's not because I'm against alternative technology, not at all. I just want them to do a fair comparison. And often I have seen comparison where the gasification facility prove that they can produce much more energy, but what they forget is the energy used for the pre-treatment. So this slide is only to remind you, take into consideration the full treatment when you compare cost and when you compare efficiency of a waste-to-energy facility. So the last slide is just to give you some guidelines where you can find more material. As mentioned in the introduction, I'm also chair of the Energy Recovery Group in the International Solid Waste Association, and we have just recently prepared some papers, a statistic of waste to energy in Europe, and a guideline for those who want to set up a waste to energy facility in countries where they have not had waste to energy before. And we have also a discussion on alternative thermal treatment methods, and I'm sure you can find some good hints there. And the Waste and Climate is a white paper. I think that Gary will tell a little more about that later, so I will not say more. So, thank you very much.
Buenas tardes a todos. Mi nombre es José Garriga. Voy a hablar en nombre de la Fundación Fòrum Ambiental y mi objetivo es presentar este trabajo. O sea, cómo la prevención y la gestión de los residuos en toda España en su conjunto, contribuye a la lucha contra el cambio climático. Son dos conceptos, residuos, cambio climático. Este estudio tiene este índice que veis aquí. Básicamente estudia unos antecedentes, explicaremos quién lo ha hecho. El sector de los residuos en España hay que explicar cómo están y cómo deberían estar. Los compromisos que tenemos en residuos en España, los retos. Y entramos en la segunda fase, que es qué compromisos tenemos España en cambio climático. Los relacionamos, vemos lo que debemos hacer y cómo, estudiamos las potencialidades y el tema básico, que es la financiación y si esto legalmente es posible hacerlo o no. Y últimamente pues voy a dar dos ideas claves de todo el estudio. Este estudio está hecho por la Fundación Fòrum Ambiental, pero han participado pues, durante 2 años. O sea, se creó un think tank que ha durado 2 años. Durante estos 2 años pues, hemos estado un grupo de trabajo de perfil básicamente técnico, no habían ideas preconcebidas, empezamos de la nada pensando sobre esto, sin tener idea de lo que saldría al final. El método del trabajo ha sido una reunión mensual de 2 horas de todos juntos discutiendo temas concretos ya predeterminados en que se sabía de qué se iba a hablar cada reunión. Los miembros de este think tank han sido básicamente personas de la Fundación Fòrum Ambiental, de la Agencia de Residuos de Cataluña, de la Oficina Catalana de Cambio Climático, del Ayuntamiento de Barcelona, la Diputación de Barcelona, l'àrea metropolitana, 2 consultings, ANFOS 21 y un despacho jurídico terraquí, el grupo ERA, Gas Natural, y hemos traído también la colaboración de técnicos de tres universidades, la de Barcelona, la Autónoma de Barcelona y la Politécnica de Barcelona. O sea, es un grupo técnico en que delante de este reto de estudiar este tema, pues basado en los criterios de la Fundación, que es la Fundación Fòrum Ambiental, es un tipo de colaboración público-privada que tiene unos objetivos y está formado por empresas privadas y instituciones básicamente catalanas relacionadas con el medio ambiente, y tiene como objetivo promover el sector económico del medio ambiente, pero con soluciones que aporten valor para la sociedad. Este es el objetivo. Los proyectos actuales de la Fundación en este tema es crear el CITREM, que habéis oído muchos de vosotros ya hablar sobre este tema, que es un centro de innovación y tecnología de residuos municipales, y el grupo de trabajo. Empecemos por estudiar el sector de los residuos en el inventario español de cambio climático. Porque pensáis que al final de todo, si vamos a tener financiación, si la tenemos, será porque bajamos las emisiones del inventario español. ¿Cómo está hecho el inventario español en cuanto a residuos, del sector de los residuos? Siguiendo las directrices internacionales, no es que sea nada distinto del resto de países para que pueda ser comparado, las Naciones Unidas dan esta pauta de que el inventario nacional en cuanto a residuos, aquí hay la comparación del año 90 y el año 2009, básicamente son depósitos en vertedero. Ya veis aquí que la cantidad importante es lo que se ha depositado en el vertedero, de manera histórica, no lo que se deposita cada año. Lo que se ha depositado los años anteriores también cuenta. El tratamiento de aguas residuales, la incineración de residuos, que no son la incineración de residuos que estamos hablando hoy, sino la incineración de residuos que son de animales muertos y otras cosas. Para no alargarme, fijaros que básicamente es depósito en vertedero. O sea, todo lo que hagamos en gestión de residuos solo será afectado directamente el inventario español lo que hagamos en depósito de vertederos y no todo lo demás. De aquí viene una de las principales cuestiones que voy a plantear yo esta tarde. El desplazamiento temporal de la degradación de los residuos hace que la tendencia al alza, por ejemplo en el caso español, no depende de lo que hagamos este año, sino incluso de lo que hemos hecho hace 15 y 20 años. Pero los residuos tienen un largo periodo de emisión, incluso de 35 años. Hay algunas algunas partes de los residuos que hemos tirado hace 35 años, que a efectos del inventario español aún cuentan. Y se tiene en cuenta solo lo que se tira cada año y al principio del año. Esto es como se hace. Y se hace bien, en el sentido de que es como la manera que las Naciones Unidas dicen que lo hemos de hacer. Otro caso es que los datos que se introduzcan sean los mejores posibles. Se han introducido estos. En el inventario del 2009, el inventario español dice que se han introducido los residuos que en España se han generado son estas toneladas y de este tipo. Y la composición, fijaos que desde el 2007 al 2008 el inventario español utiliza el mismo sistema. Hagamos hecho lo que hayamos hecho, siempre es el mismo durante el 2007 al 2009. Esto es cómo se ha hecho. Pues explicaré que gracias a muchas intervenciones y a muchas peticiones, cada vez se está haciendo mejor. Pero esto es cómo se ha hecho hasta ahora. Tenemos, por lo tanto, un sistema de inventario de emisiones en España que solo tiene en cuenta las emisiones que nosotros llamaríamos directas, las de vertedero, pero no tiene en cuenta las indirectas. El ejemplo clarísimo, por ejemplo, es las emisiones debidas al combustible del transporte de recogida de residuos. Este se cuenta en el sector de transporte, de energía, y tampoco se tiene en cuenta las emisiones que la buena gestión de los residuos puedan hacer en evitar residuos. Cuando una buena gestión de residuos en España evita una emisión de CO2 en el sector de la energía, no se cuenta en el sector de los residuos, sino en el sector de la energía. Este es el cuadro que se ha presentado también esta mañana, que se ve clarísimo que España pues, tiene mucho recorrido. Lo que estamos haciendo es exactamente lo que pone aquí, el 2010. Estamos tirando mucho a vertedero, el 58%. O sea, somos de los países del medio de Europa, pero de los que tenemos un recorrido grande en tema de gestión de residuos. Lo debemos hacer mucho mejor y lo podemos hacer mucho mejor. Bueno, esto en cuanto a residuos. En cuanto a gases de efecto invernadero en España, bueno, esto se me va a caer, lo voy a dejar en el suelo y no se me va a caer. Básicamente, España tiene, yo lo he dividido en 4 compromisos distintos, unos de muy claros y otros que los puedo intuir. En cuanto a gases de efecto invernadero, España tiene el compromiso de cumplir con el actual protocolo de Kioto. Dura del 2008 al 2012, sabemos exactamente la cantidad que podemos tirar sin ningún coste, porque tenemos un compromiso europeo de no pasarnos de un 15%, que a efectos prácticos es un 17%, porque hay un 2% que nos podemos restar por la acción de los bosques españoles, pero a la hora de la verdad, todo lo que nos pasemos de 338 millones de toneladas de promedio de los 5 años, de una manera o de otra, o las empresas españolas o el Estado, que es el responsable de que cumplamos, pues tendremos que pagar. Tiene un coste cumplir el protocolo de Kioto y el no cumplirlo tiene un coste elevado. El segundo gran compromiso español es el paquete de la energía y clima, básicamente, que es un compromiso de ámbito europeo. Europa se auto-obligó a cumplir para el año 2020 unas reducciones que de momento son del 20%, y si no cambian continuarán siendo del 20%, pero que Europa también dijo que si el resto del mundo hacía unos esfuerzos similares, pues pasaríamos al 30%. De momento estamos con el 20% y este compromiso ya nos obliga a cumplir una serie de requisitos. Pero esto no se acaba aquí. Esto va a futuro. ¿A futuro qué pasa? Bueno, sabemos clarísimamente que hubo un acuerdo político, de voluntad política en Copenhague, para rebajar las emisiones a nivel mundial en un 50%, para no pasarnos de los 2 grados que es admisible que nos pasemos para no atentar contra el sistema del clima mundial. Este es un acuerdo político de Copenhague que se apuntaron muchos países, no todos, pero que Europa se apuntó. Este compromiso fue ratificado ya en la reunión de las Naciones Unidas de Cancún al año siguiente. O sea, lo que había sido un compromiso político se convirtió en un compromiso ya dentro del marco de las Naciones Unidas y este acuerdo lo tenemos que cumplir. Como hemos dicho, el 50% entre todos, bueno, aún no sabemos cada uno lo que tiene que hacer, pero se puede intuir perfectamente que nosotros, los países desarrollados, pues si a nivel mundial es el 50%, lo que tendremos que cumplir nosotros es mucho más alto. Bueno, también existen los acuerdos de Durban del año pasado. Aquí nos comprometimos a algo más ya. Los europeos nos obligamos delante de las Naciones Unidas, y está en los acuerdos finales de la última noche de Durban, que nosotros, los europeos, estamos de acuerdo en un segundo periodo del Protocolo de Kioto. Nosotros y algunos más. Vamos pocos en este viaje, porque hay muchos países pues, que se han desmarcado. Japón, Canadá, de los que íbamos juntos, unos cuantos no siguen, pero nosotros seguimos. ¿Este compromiso qué implica? Pues implica, fijaros, que para el periodo que empieza el 2013 y acaba el 2017 o 20, Europa propone el 20, pero en Durban se pactó que se acabará este segundo periodo del Protocolo de Kioto o el 2017 o el 20, pero no más tarde del 20. ¿El compromiso cuál es? Que los países que asumamos reducciones para este segundo periodo del Protocolo de Kioto, agregadamente, pues hemos de rebajar nuestras emisiones comparadas con el año base que teníamos el año 90, entre un 25 y un 40%. Pensar que Europa, de momento, su compromiso es del 20%, pero en Durban ya estamos entre el 25 o 40%. Pero como aún no sabemos agregadamente lo que nos va a tocar, pues no lo sabemos exactamente. Pero yo intuyo que será como mínimo superior al 20% que tenemos ahora, porque si somos pocos y nosotros nos reducimos como mínimo un 25 o un 30%, pues no cuadrarían los números. Aquí he hecho un cuadro en el que se ve perfectamente el sector directiva y el sector difusos de España. Después veréis por qué, porque el sector residuos está en el sector difuso, y esto es muy importante. Bueno, el sector directiva, las emisiones del año 90 no lo sabemos, no existía la directiva. Hemos empezado a tener información a partir del 2005. El 2005 sí que sabemos qué emitieron las empresas que estaban en el sector directiva español, que son más o menos unas 1000 empresas, y por resta sabemos cuáles son los difusos. Antes no lo sabíamos. Bueno, sabemos también las emisiones de España del 2010, tanto de directiva como de difusos. Tenemos los objetivos del programa que os he explicado de energía y clima para el 2020, con los topes. Y tenemos muy claro el compromiso de Kioto 2, yo lo llamo Kioto 2, y el compromiso que agregadamente todos los países desarrollados del mundo, que son más o menos 40, tendrán que hacer entre un 80 y un 95% de reducción para, sumada a las reducciones o aumentos del resto del mundo, no pasarse de aquel 50%. Porque en cambio climático hay un concepto global y después hay que dividirse localmente o por regiones o por países. Lo que queda claro es que a donde vamos es a una reducción sustancial de todas las emisiones de todos los países desarrollados comparados con las que teníamos el año 90. Esto no tiene vuelta de hoja. ¿Cuánto exactamente? Pues está delimitado el primero y el segundo objetivo. El del último no, pero básicamente, si estamos hablando ahora de 25, 30 y hemos de pasar a 80, 85, a 95, pues se tendrá que hacer un esfuerzo bastante difícil, pero que se tendrá que hacer, porque los países que históricamente estamos tirando más gases y que tiramos, por decirlo así, por habitante año, 8 o 9 toneladas por habitante año, pues estamos comparándonos con otros países del mundo que están tirando 1 tonelada, 2 toneladas, y lo que cuenta para cambio climático es lo que hagamos entre todos. Visto esto, pasamos al tema de qué grandes informes internacionales. Hemos seleccionado unos cuantos, hay muchos, El grupo de trabajo estuvimos estudiando información sobre el Reino Unido, Francia, Estados Unidos, Canadá, las Naciones Unidas. En el trabajo, en el estudio que vamos a presentar y va a estar en la web en el periodo de un mes, antes de un mes estará en la web de la Fundación Fòrum Ambiental, hay una larga bibliografía que hemos ido estudiando este equipo de personas durante estos 2 años. Pero vamos a escoger unos cuantos de informes internacionales. Bueno, hay un programa de medio ambiente en las Naciones Unidas que tiene un informe sobre los residuos y el cambio climático del 2010, que es muy importante. La Agencia Europea de Medio Ambiente también ha tratado este tema. La Agencia Federal de Medio Ambiente también tiene un informe que empezó en 2005 y ha revisado en 2011, que estudia el sector de los residuos de manera integral, no solo el que va a la directiva directamente, sino todas las emisiones que se pueden no solo reducir, sino evitar, la Comisión Europea. ¿Y qué potencial de reducción tendríamos en el sector de residuos en España? Bueno, nosotros empezamos a diseñar un concepto de decir qué tenemos que hacer obligatoriamente, o sea, cuál es el escenario legal que tiene España. Pues el europeo, traspasado a la legislación española, mediante la Ley de Residuos y Suelos Contaminados del 2011. Con respecto a esta ley, hay que decir que cuando la ley se presentó en el Parlamento Español, en el Congreso, no había ni una sola mención sobre cambio climático. O sea, salió aprobada del Congreso Español y no hablaba nada de cambio climático. No existía el cambio climático para los residuos. Esto era grave, porque si no hay una relación directa entre la gestión de los residuos y la lucha contra el cambio climático, lógicamente después no se podrá pedir que financiación para luchar contra el cambio climático vaya a los residuos. Entonces nosotros la Fundación pedimos una reunión, pedimos ser recibidos en el Parlamento, nos recibieron, yo fui personalmente a una comisión de trabajo del Congreso y el Senado y nos hicieron caso. Y entre el Congreso al Senado, pues se introdujeron unas enmiendas que aprobaron todos los grupos políticos, nadie votó en contra, y ahora en este momento en la ley esta hay pocos, pero hay 3 o 4 artículos que hablan de la necesidad de que los planes de gestión de residuos en España tienen que tener en cuenta la lucha contra el cambio climático. Esto es una ventaja. Si no lo hubiera habido, pues el problema era grave. Pero gracias a Dios, aunque fuera tarde, nos escucharon. El escenario, por lo tanto, legal, es el que tenemos. Y este nos obliga a hacer una serie de cosas. Pero nadie nos impide presentar un escenario avanzado. O sea, un escenario en el cual hacemos una serie de acciones con mayor valor socioeconómico, medioambiental y de creación de empleo estable. Esto, lo que es obligatorio lo tendremos que hacer, pero hay cosas que no estamos obligadas a hacer, pero que si las hacemos, bajaremos las emisiones de gases de efecto invernadero en España, y si fuéramos compensados económicamente por hacerlo, lo podríamos hacer y además ganaríamos muchas cosas. El sector España, el empleo, la balanza de pagos. ¿Por qué? Porque lo que hagamos reduciendo emisiones en el sector de residuos, como en muchos otros, pues son inversiones que quedan dentro del país, dentro de España, y son menos derechos de emisión que hemos de comprar fuera. O sea, una de las malas experiencias de la primera fase del protocolo de Kioto para España ha sido que sí que vamos a cumplir lo que nos comprometimos, pero a base de 2 cosas. De tener la desgracia de la crisis que tenemos, e incluso teniendo la crisis que estamos teniendo económica desde el 2009 para acá, incluso así hemos tenido que pagar muchísimo. Nos cuesta mucho dinero el comprar derechos de emisión fuera para cumplir con el protocolo de Kioto. Esta experiencia la hemos de tener en cuenta para los segundos y terceros periodos. Todo lo que se puede hacer dentro de España hay que procurar hacerlo, siempre que sea más rentable que comprar fuera, y muchas veces lo es, pero hay que contarlo todo, no solo contar el coste de comprar fuera o el coste de hacer las cosas dentro, sino hacer un estudio global de todo lo que nos ahorramos haciendo las cosas dentro del país. Este escenario avanzado y este escenario legal lo comparamos. La Fundación ha encargado a la Universidad de Barcelona un simulador que también estará en la web de la Fundación, en el cual se pueden cambiar los parámetros. Nosotros, el grupo, hemos consensuado una serie de soluciones, pero el simulador permite que las soluciones sean distintas. Este simulador ayuda a este informe a entender cómo serían las cosas si las hiciéramos distinto de cómo las hacemos. El modelo de cálculo, por lo tanto, también es un modelo de cálculo abierto, encargado por la Fundación a la Universidad de Barcelona, y el escenario de estudio es el 2020, pero este simulador podría servir para otro día. De momento lo hemos hecho para el 2020. El simulador lo que nos dice, fijaros, es que la situación actual... Partimos del principio que los últimos datos que teníamos fiables, el grupo de trabajo, eran las del 2008. Entonces, utilizamos el simulador con el 2008, hicimos un escenario del 2020, contando que el tipo de residuos que tendríamos serían los mismos, ni subirían ni bajarían, pero en principio se pueden hacer bajar o se pueden hacer subir, pero para que la comparación se viera que no era porque bajaban el nivel de residuos o de basuras que teníamos en España, sino siendo lo mismo, aquí tenéis pues, el escenario legal, qué pasaría, y si fuera el avanzado, qué resultados tendría. El avanzado en el estudio explica cuál es exactamente. O sea, yo os recomiendo que os miréis las 60 páginas completas del estudio para entenderlo. Hemos intentado hacerlo resumido, pero no se puede explicar aquí solo en una hora. Yo recomiendo que os lo miréis y busquéis la punta del tema que tiene. ¿La conclusión cuál sería? Pues que si hiciéramos un escenario avanzado de gestión de residuos en España, no el legal, no solo aquí fijaros que tenemos en cuenta las emisiones directas, las indirectas y las evitadas, y puestas a cada uno a lo que le toca. Pero al final la suma de todo es que España tiene menos emisiones. Y si España tiene menos emisiones, pues va a cumplir más fácilmente los compromisos internacionales que tiene. El escenario legal, continuamos teniendo emisiones del sector residuos, y en el avanzado pues tenemos muchísimas más ventajas, porque en el avanzado hay muchos más créditos, por decirlo así, de sectores de la directiva. Como es lógico que sea, cuando mejor hagamos las cosas, más evitaremos la emisión de CO2, porque la buena gestión de residuos lleva aparejada la bajada de las emisiones. Aquí tenéis en un cuadro del año 90, el 2008, el legal. En el avanzado, por decirlo así, seríamos, que no lo sería, a ver si los explicar bien, no es que nosotros descontemos, tengamos emisiones menos, sino que en algunos sectores del inventario español se les habría bajado las emisiones de tal manera que sería esta cifra, no en el sector de residuos, pero gracias al sector de residuos. El ejemplo claro es que todo lo que recuperemos de los residuos, tanto en energía como en productos, son productos que no se tienen que fabricar, o energía que no se tiene que comprar, o energía que es nacional, por decirlo así. No es energía fósil que compramos. La financiación de estos proyectos, porque aquí hay una cosa muy clara, se pueden hacer los planes que quieras, pero sin financiación los planes quedan en un cajón. Por lo tanto, ¿dónde está el sistema de financiar un programa de estas características? Mirad, la Directiva de Comercio de Derechos de Emisión habla de que van a haber del sector directiva español, dentro de un contexto europeo, no ya solo español, sino europeo, se van a producir una serie de subastas de derechos de emisión. Y a España le corresponde un tanto por ciento de la subasta europea, no de la subasta española, que no existe. Existirá una subasta europea, a nivel europeo. Pensad que el cambio cualitativo importante entre los compromisos que tenemos hasta el final del 2012 y los compromisos que vamos a tener a partir del 1 de enero del 2013, el cambio cualitativo es que todo lo que hacíamos a nivel nacional de cada uno de los Estados europeos lo vamos a hacer en el conjunto de Europa. Todo el conjunto de las empresas o instalaciones que están dentro de la directiva europea van a bajar un 21%. Todas van a ser tratadas igual, todas las empresas, por ejemplo, del cemento, de la energía, de toda Europa. Entonces, este sistema consigue el recaudar unos fondos que van a través de una subasta europea que algunas de las instalaciones empiezan a pagar no lo que les falta, sino desde la primera tonelada. Por ejemplo, el sector eléctrico europeo va a pagar básicamente desde la primera tonelada que tire. Tendrá que comprar derechos. Estos derechos, la legislación europea habla de que se tienen que destinar básicamente a la lucha contra el cambio climático, pero no concreta. La legislación europea no concreta. La española concreta, el Parlamento Europeo ha dado directrices, pero la legislación española en su preámbulo, no en su articulado, esto es importante, dice lo que dice el Parlamento Europeo, de que el dinero que se saque de las subastas tiene que ir básicamente a tres finalidades. Primero, a la finalidad de los compromisos internacionales que tiene la Unión Europea, o sea, ayudar a terceros países a cumplir sus compromisos de lucha contra el cambio climático. Esto es una parte. Lo que Europa dice que va a hacer para ayudar a terceros países que no son europeos, o sea, que son a nivel mundial, les vamos a ayudar a hacer cosas, ¿el dinero dónde saldrá? Pues una parte de la subasta europea. La otra parte viene de ayudar a Europa y a los Estados a cumplir con sus obligaciones de cuidarse de la adaptación al cambio climático, no de la mitigación, la adaptación. Pero una tercera parte, y es importante, es para que los países, los Estados europeos, hagan políticas de mitigación en el sector difuso, donde no había fondos. El difuso no es el que está en la directiva, y es donde está básicamente el sector de los residuos. Estos fondos, por lo tanto, el Estado español los puede destinar básicamente de momento a donde crea más oportuno, pero tiene que dar explicaciones a Europa de lo que ha hecho de ellos. Fijaros que corren muchos rumores de que el dinero de las subastas de España irán en gran parte a mitigar el coste de la factura eléctrica. Bueno, esto es muy complicado de hacerse. Se puede decir, pero es muy difícil de hacer, porque la verdad no está para esto, no está directamente relacionado con esto. Porque el sector eléctrico español, el sector eléctrico español está en el sector de la directiva, no el difuso. Bueno, como tengo poco tiempo, miraré de correr un poco más. Básicamente, la viabilidad económica es posible. Nosotros hemos calculado que a un valor de 20 euros por tonelada serían 400 millones de euros al año. La ventaja de la subasta es que es cada año. Y en principio las ideas clave es que España tiene grandes potencialidades y grandes sinergias para unir la política de cambio climático con la política de residuos. No resuelve todo el problema de los residuos, pero ayuda. El segundo tema es que es necesario que el sector pueda convertir en ingresos su contribución al clima. Esto es posible legalmente. Falta que haya voluntad política de hacerse, pero se puede hacer. Sería conveniente, por lo tanto, que el sector de la gestión de los residuos municipales en España, el sector, básicamente el gobierno central, las autonomías, las administraciones locales, y consensuaran un programa para que tuvieran en consideración este tipo de cuestión del cambio climático. ¿Y todo esto para qué? Pues sencillamente para poder defender delante de la Unión Europea un plan de gestión de residuos municipales que cumpla la legislación europea, que ayude a luchar contra el cambio climático y que pudiera servir para una colaboración del Banco Europeo de Inversiones para el relanzamiento de la economía española, que un día u otro tiene que empezar. O sea, hay que buscar fondos donde los hay para proyectos concretos. Este es un proyecto concreto y posible. Y este estudio que hoy presento y os ofrezco es el punto de partida de este tema. No, se tiene que buscar la manera de que todo el sector de los residuos presente un plan en Europa para poder financiar un plan que reduce las emisiones en España mejora la gestión de los residuos y además ayuda a crear empleo, a no tener que comprar fuera derechos de emisión. Es un programa de win-win, saldríamos ganando todo. El reto está abierto, pero si no nos lo planteamos, no lo conseguiremos. Muchas gracias.
Well, good afternoon. I would like to start by thanking the chair for the introduction, and also I'd like to say that I'm very pleased to participate in this conference. I would like to thank the organizers for inviting me. And as noted, my presentation is entitled Scaling Up Climate Benefits from Waste Management and Recycling. I'm really pleased. As noted, I'm the chair of the Working Group on Climate Change and Waste Management for ISWA, the International Solid Waste Association. In my day job, I oversee the corporate sustainable development function for Veolia Environmental Services, and I was really pleased to see that the organizers decided to dedicate a session to waste and climate change. So let's get into this a little bit. I know I have to go quickly. The clock is running. So just to get into an introduction, stabilizing the levels of greenhouse gases in the atmosphere requires really a broad portfolio of actions across all sectors. The waste sector should be part of this portfolio as it offers immediate, cost-effective, and fast-acting opportunity to achieve GHG savings. It will be necessary, however, to considerably scale up the mitigation efforts, as you've heard, especially in developing countries. So on this slide, I'd just like to point out that waste management can be a catalyst for the circular economy. There is a growing demand for sustainable waste management and production cycles in a rapidly growing and urbanizing world. There's a strong need for resource efficiency, which contributes significantly to the reduction of greenhouse gas emissions, really looking at turning waste into a resource. So on this slide, I hope you can read the text, but we know that waste activities, as you've heard, do generate greenhouse gas emissions. However, as shown here, we have a number of actions which can contribute to emission reductions. These actions either reduce the direct emissions or actually increase the avoided emissions. And I won't name them all, but they're actions such as more fuel efficiency in the collection activities or alternate transportation, increasing recycling or composting, and also increasing the production of substitute fuels, increasing energy recovery from waste-to-energy plants, and also, as we've heard, maximizing landfill gas collection. We need to promote these greenhouse gas benefits of the actions within the waste sector, and I'll touch on a few of these in the coming slides. So this next slide, before I do that, I would like to quickly reference a European example. This graph was actually taken from a study prepared by the European Environmental Agency. Progress in reducing greenhouse gas emissions in the EU between 1990 and 2008 were made in large part through policy and regulations based on the waste hierarchy. The legislative framework included specific targets and directives regarding packaging waste and also the diversion of organic waste from landfills. On this table, what you see, I can't point it out. There we go. So that's okay. But you see on this graph is actually a chart that's looking at the progression of greenhouse gas emissions in the EU based on this study. And what's positive bars, or what's above the zero line, is actually the direct emissions that come from a number of the waste activities. What's below, or shown as a negative, are the avoided emissions, which come from energy and material recovery. And those are shown as negative values. What you see on this same graph is this red line, which is really the observed overall net reduction. And it's in large part associated with the increased recycling and incineration. This study estimates that the net annual emissions from municipal waste management in the EU have reduced by approximately 48 million tons of CO2 equivalent from 1990 to 2008, not insignificant. And the study estimated that another 62 million tons of CO2 equivalent will be reduced by 2020 as the EU landfill directive is implemented. So I'll now show the obligatory slide that you have to have in at least every other presentation, but mine is a different color here, but it is the same slide you've been seeing. In mine, you see that the landfill is, and it shows the different treatment alternatives, landfill in purple, incineration in yellow, recycling in blue, and composting in light green. And as mentioned, we still see a significant number of countries where landfilling is the main treatment alternative. So there is still a significant opportunity, although we've seen in the past study we've made some progress, but opportunities to scale up energy and material recovery solutions in the EU. This next slide lists, and that's based on the regulations that are now in place, the directives in place. This slide I won't get into the details here as I need to fast forward as much as I can, but it's just to note that we see that there are a number of EU initiatives that will continue to, that are looking at resource management and also waste as a resource, and we can see that these will continue to contribute to a low-carbon economy. And I just wanted to note that in this session we are speaking about climate change and the climate benefits, but it should be noted that there are a number of other benefits that are associated with waste projects, environmental, economical, and social benefits, and these are in addition to the greenhouse gas emission reductions. I won't say more on that. And so I'll now like to do, as I mentioned earlier, I will explain to you some of the sector's actions to reduce greenhouse gas emissions in a little bit more detail. I need to start with landfill, as we know that landfills are the major contributors to climate change in the waste sector through their fugitive methane emissions. It's therefore really a priority to reduce the direct emissions from this activity and also increase the avoided emissions which would come from using the landfill gas as an energy source. The one measure to reduce this is obviously to reduce or ban landfilling of organic waste, as we've seen in the EU. The key action for landfills that are actually accepting organic waste is, of course, to include active landfill gas collection and treatment systems. And there's been a lot of progress on this in the last 25 years. In the industrialized countries, where in a majority of the industrialized countries, we see that these have installing active systems has become mandatory through regulation. For example, we see the fugitive methane emissions have decreased significantly. We look at Europe's emissions from landfills have decreased by 40% between 1990 and 2008. Down under in Australia, we see that the emissions from landfills decreased almost 13% between 1990 and 2005. And then lastly, in the United States, we see that the emissions from landfills decreased 20% between 1990 and 2009. So there's still continued efforts in this area, as there are still landfills that either with historic waste or continuing to operate that are need to capture and improve the efficiency of capture of the landfill gas. So staying on organic waste, organic waste is one of the major components of municipal solid waste, and it's really, as I said, responsible for the fugitive methane emissions. So what we know is that organic waste can actually be recovered even at a small scale on a local level. So there's really also a large potential in the developing countries where the organic content of the waste is quite high. The use of biologically treated organic waste as a soil amendment can contribute to avoided greenhouse gas emissions resulting from, one, the reduced production and importation of mineral fertilizers, secondly, the substitution of peat in the production of growth media, and the third, just the binding of that carbon in the soil or sequestration. And what I have listed or shown, and we can cite the first large-scale composting project that was registered as a clean development mechanism project by the CDM Executive Board, and it's located in Dhaka City in Bangladesh. And the project includes the design, the build, and operation of 3 composting plants. 50,000 tons of compost will be produced, contributing to close to 90,000 tons of CO2 equivalent per year. And it has been really a model on how this can be replicated through Southeast Asia. So this is a blank slide. No, actually, I just want to point out that waste is a reliable worldwide supply of clean energy. We saw earlier today, we know that this is can come from waste energy, but also from anaerobic digestion and the capture and use of methane at landfill sites. And we see that these technologies obviously are already contributing. And I have the first box that you see is a little bit outdated. I heard some new numbers this morning, so this will have to be updated. But at the time, which is now probably 30% higher, but we see that it was estimated globally in the first reference that from the WTERT that 130 million tons of waste are incinerated every year, and over 600, now it's much more than 600, producing at the time the equivalent electrical energy of approximately 10 million European consumers. So we see that it's quite important and increasing, and we'll look to update that. But in addition, what we see with regard to energy production from biogas in the EU, we see that a total of 8.3 million tons of oil equivalent was produced in 2009, and this is a 4% increase from 2008, and we've seen that this is steadily increasing. What's interesting is that 52% of the primary energy from biogas is actually from anaerobic digestion plants, and 36% from landfill gas, which in some years ago was actually more important than the AD plants. So what we see is these energy from waste solutions can certainly be scaled up. And now to add another facility on the many examples you've heard during the course of the day, I've used an example from Sheffield in the UK, and the city has taken a very proactive environmental approach, including commitments on greenhouse gas emissions. In Sheffield, a new energy from waste plant was built in 2005 and 2006. It's part of an integrated waste management contract. The capacity of the plant is 225,000 tons of waste per year. And Sheffield has an award-winning district heating network that's providing heat and also hot water to over 140 buildings. And this includes more than 45 kilometers of pipeline, delivering a low-carbon energy source. The energy production capacity is up to 60 megawatts of thermal energy and up to 19 megawatts of electrical energy. And you see on the slide the avoided emissions based on our environmental reporting for 2011, and a total of 68,600 tons of CO2 equivalent were avoided from electrical and thermal energy sales. Okay, so let's keep moving. Turning waste into a resource. Recycling, reuse, and waste minimization represents an important and growing opportunity for indirect reduction of greenhouse gas emissions, as we know from the conservation of raw materials, improved energy efficiency, and fossil fuel avoidance. What I'd like to do very quickly is reference some. We see more and more examples of closing the loop in countries, putting waste management and resource efficiency in practice. The first example is an integrated waste management contracts, such as the private finance initiative that contracts in the UK. And it was really looking at it from a global standpoint, looking at the management system from collection right on through to recovery. And the objectives were to develop an appropriate infrastructure that would help to deliver the required level of recycling and recovery. And that's material recycling, energy recovery, and also composting are within most of these integrated waste management contracts, a global approach. And also, as part of that and integrated into these contracts is looking at ways in which to reduce the waste production, restrict the volume of waste sent to the landfills, obviously, and then, as we heard this morning, a very key element is to awareness and progressively changing the public attitudes and behavior toward waste. And that's very essential, as we heard. And this has really helped in these specific contracts to increase recovery rates. The next one I'll move on to is the state-of-the-art sorting centers. And here, one trend we have seen in non-hazardous waste recycling facilities is increased industrialization of the plants to handle greater volumes and provide better quality output, either as recyclables or as refuse-derived fuels. Sorting waste is really turning more and more industrial and on an international basis as proven technologies from some other industries or agriculture are actually adapted to the waste business. The equipment can include things like optical sorting systems, trommels, magnetic separators, and eddy current separators. So we see more advanced technology being used in the sorting facilities. Now I'll move to a bottle-to-bottle recycling, and this is a facility that I'm referencing, and it's a waste recycling plant that actually collects and recycles 500 million used plastic bottles a year, and it enables the production of new bottles, and it's saving about 28,000 metric tons of oil. So again, one facility looking to close the loop. And then finally, just a reference to a site that has been designed as the first second-generation plant in France producing biodiesel from used cooking oils and other greasy waste. And it was commissioned in 2010. It'll eventually work up to convert 40,000 metric tons of waste oil into biofuels each year. So just some examples of seeing how industries and working towards closing the loop, really looking at it as resource management and not waste management. So how am I doing? Is it 4 minutes? Okay, that's all right. We're going to go a little faster now if you don't mind. So transferring technology through the CDM, the Clean Development Mechanism, the transfer of sustainable technology to developing countries is really crucial to reduce greenhouse gas emissions. This is already happening. The Clean Development Mechanism, which was actually introduced through the Kyoto Protocol, has really provided an opportunity for the waste sector to make advances in this goal. And we see that the CDM has been successfully implemented at over 4,600 registered projects in all sectors, and there are more still in the pipeline. The waste sector represents about 13% of these registered projects, and we see that, however, it's moving through. There's been some improvements, but it's been, the CDM has struggled with some lengthy procedures for registration and credit issuance, but it's made its way through with close to, probably will approach more than 5,000 projects registered. But it does, through this process, leads to some uncertainty on the outcome. And while I'm briefly talking about uncertainty, we've heard about the post-2012 period and what will become of the markets, international markets. We know that the main user of the credits from these projects is the EU ETS, the Emission Trading Scheme, and we see right now that there's an oversupply in that system, so the need for these credits is diminished, and also there's some uncertainty about which types of projects will be eligible in the further periods. So in summary, what that leads to is lower prices for the credits at this point in time, and hopefully the international discussions at the end in December will have some impact on that. But we're talking about CDM project. I'll just reference one. Landfill, we've seen that there is the transfer of technology. This project, really by chance, is the same site that was referenced this morning by Mr. Molina when he was speaking about Colombia. It's a landfill gas project, Donawana in Bogota, Colombia. It's a registered project. It's including the capture, treatment, and utilization of landfill gas. In this project, there's flaring, but there's also intended use to use the biogas for electricity production and also to use it as a fuel source in neighboring brick factories. And it's a large project that will produce close to 6 million tons of CO2 equivalent over the first 7-year crediting period. And the project is now producing credits. So I'm moving along. We can see that what I just wanted to point out here is that we do see that there are significant advancements towards material and energy recovery. It's taking place, but there's still a lot we can do. And as shown on this slide, and it's based on a world waste survey conducted by Cyclop, only 25% of the worldwide waste is recovered as material or energy. And we know that the waste volume is growing. It's really essential that the integrated waste management solutions are deployed right away to achieve sustainability and environmental goals. So there's a huge potential to do that. Now, I know I don't have a lot of time to get into this subject, but another way that we could really consider scaling up, how do we scale up? Well, one solution could be what is called NAMAs, which is the nationally appropriate mitigation actions which have come under the UNFCCC discussions. And it's a solution for immediate scale-up of will be used or could be used for waste sector. And it's a new mechanism. And this new mechanism is intended to attract financial and technological assistance in organizing these large-scale projects to get away from some of the project-by-project mechanisms that exist today. I definitely won't get into the detail on this slide, so it's just to say that it was started in the UNFCCC discussions in 2007 under the Bali Action Plan. It went through, and initially it was developed as a solution, and you see the text on the slide as its definition. Very light definition at first, and it went through the Copenhagen and Cancun meetings. And it's really, I'll go to the next slide to get away from the description of the regulations and the timing. I'm out of time, I see. But what are NAMAs? Essentially, they're voluntary mitigation actions that can be implemented by a developing or even a developed country, but it's any government-sponsored policy, program, or project that results in measurable greenhouse gas emissions, but it has to be compared to a business-as-usual scenario. As I already pointed out, it's really meant to scale up both greenhouse gas emission reductions and finance provided under the CDM and other climate finance mechanisms. I won't get into the detail of how these are intended to be financed, and there's a lot of discussion ongoing in this area. So what I will just say is that as the discussions are ongoing, it's really important that NAMA should include sustainable waste management and recycling. The sector has proven experience and capabilities in the following key elements of the NAMAs, which is described under the NAMAs. The technology transfer we talked about. We heard and saw some examples of policy examples. There are definitely sustainable development co-benefits, capacity building. There's experience in the sector in capacity building, and also there are proven monitoring, reporting, and verification methodologies, and also experience in financing of waste management projects. So yes, I'm coming to the conclusion, and just last slide, I have one more, but anyway, the conclusion really, as you can read along, is just that improved waste material management and resource efficiency can bring significant greenhouse gas emission reductions. I hope you got that message from me today, and that there are proven and cost-effective waste management technologies and approaches that deliver sustainable development benefits. These areas should really be included and be included and considered in the future international discussions and agreements. And it's essential that these messages are communicated to international, national, and local policymakers to encourage the implementation of these local solutions to help address this global problem. So I should just point out that ISWA has been working and will continue to work to disseminate these messages, maybe a little slower, in international and national discussions. And I just would like to thank you for your attention. I'll say one more word. If you please could, you have the ISWA website address. Please go there and you can look at the white paper and some other documents that we prepared on the subject if you'd like more information. Thank you.
Bueno, la más sincera enhorabuena porque hemos conseguido que no se duerman habéis conseguido que no se duerman los oyentes. ¿Alguna pregunta?
Sí, buenas tardes. Quería hacer una consulta a Bettina porque ha habido dos aspectos que realmente llaman la atención de la información que nos ha dado. El primero era... ¿Se oye bien? ¿Sí? Pues sí. El primero era sobre el aspecto llamativo, ¿no? De cuando ha mostrado el mapa del número de plantas de valorización energética que hay en Dinamarca. Un número importante, casi un número apreciable, casi llevable a un ratio por ciudadano. ¿Y qué clase de aceptación, dado que parece ser que es una tecnología de tratamiento, pero además un sistema de producción de energía muy claro, que tienen muy claro en el país, la aceptación que tienen por parte de los ciudadanos. Luego también el otro tema que me había llamado la atención es el hecho de que se llegara a una separación de la materia orgánica, se dejara de realizar la recogida separada de la materia orgánica y ahora se lo estén pensando. Lo digo porque más que nada porque aquí es lo que estamos haciendo, ¿no? Es decir, estamos recogiendo la materia orgánica con unos costes muy importantes y incluso separando la materia orgánica de rechazo con unos costes aún más importantes y luego unos grandes costes para poder llevarlo a los vertederos. Y en ambos temas, ¿qué opinión o qué recomendación, si conoce, y ahí ya como RAMBOLL, dada la ingeniería consultora del tamaño que sois, si tenéis una opinión formada sobre qué está pasando en España o si podéis hacer algún tipo de recomendación o te atreverías a hacernos algún tipo de recomendación?
First of all, to the public acceptance, I would say it's extremely high in Denmark. We have, of course, a procedure, as we have in all European countries, where you have public hearings before you will have the permit for a new waste-to-energy facility. And I have been to many public hearings. One example is some few years ago, there was a public hearing. There were only, in addition to the politicians, there were 2 participants. It is an extreme situation. We are also doing public, I have participated in public hearings in Canada and in the US. There were 200 people, so it's a completely different situation. I think one of the reasons that we have such a high public acceptance in Denmark is that we have such a high energy efficiency. So people are, first of all, they're used to the waste-to-energy facilities and they can see that they gain the energy from the waste. We have also done a lot of out of the architectural appearance of the facilities. In former time, it looked like an ugly industrial facility. Today, we have integrated the facilities into the city, and we have, of course, used some money on the architecture and, of course, also on the equipment itself, but that is perhaps more logical. But I think that's one of the reasons that we have the high acceptance. To your second question is about the collection of the bio-waste. When it was introduced in the mid-90s, it was a political decision taking that we should do separate collection on bio-waste. And people were very enthusiastic at that time. We have a very big, everybody wanted to do something, and all inhabitants felt that it was their duty to collect in 2 waste streams. So it was very easy to implement the system. But then we realized technical problem at the facilities, mainly due to the fact that people could not find out sorting the waste in the right manner. There were components that should not be in the bio-waste. It created technical problems at the facility. There were an awful order from the facility itself, and the gas that was produced was not stable enough to drive the gas motors. It cost a lot of money, and it costed a lot of political prestige to close those facilities. And after that, there was a lot of discussion in the newspaper that what does it mean that we should collect in 2 waste streams when the plants are not operating, and the municipality, they will just put all in the same waste bin, even though we are doing separate collections. So it created really problems in Denmark. And as I said, the Danish EPA came up with the conclusion that if you look at the environmental and the financial and environmental situation in Denmark, it was as good to go for waste-to-energy. The reason that it is coming up today is due to the resource discussion, that we want to get the carbon back to the nature. That is the main driver today to maybe introduce anaerobic digestion again. And I think what we will not do this time is to, or said in another way, I think we will focus on the industrial bio-waste and perhaps not introduce it so heavily in the municipal, in the households, private household. So the main part of the bio-waste will come from large kitchens, from industries and so on, and it will be mixed with manure. We have just implemented the biggest anaerobic plant in Denmark. It is in commissioning now, and it is based on a small amount of waste and a large amount of industrial waste and manure. We do not do MBT. I know that is widespread in Spain, and a lot of discussion about that is going on, as far as I'm informed. We will not do that in Denmark because we do not believe that the bio-waste will be clean enough. So we will go for source separation. At least that is how it looks like now. I hope I answered your questions.
Queda pendiente si existía por vuestra parte algún tipo de recomendación o algún tipo de opinión sobre la situación en España. ¿Me ha podido oír? Sí.
I could not hear that.
Quedaba pendiente la última pregunta, que era como consultora en ingeniería, como RAMBOLL, algún tipo de opinión, si conocéis la situación en Cataluña y en España, preguntar un poco vuestra opinión sobre cómo se está haciendo aquí, ¿no? Es decir, la separación de la materia orgánica en los hogares y la separación de la materia orgánica del rechazo, recogido como rechazo en las ciudades.
I'm afraid that I will perhaps interfere too much in the political discussion going on here in Spain, so I would prefer not to come with a direct answer to your question.
Bueno, pues ahora, como sabéis, tenemos descanso y os ruego puntualidad para el comienzo de la siguiente sesión, que ya es la última del día. Muchas gracias.